Right, it's very unfortunate that a number of your classmates are not here. Okay, because this part which I'm starting now is very, very important. All right, so just to do a quick recap. So yesterday I introduced the 5 formulae which are called the general solution of trigonometric equations. Right? There are 5. It's not 4. Right? So just to do a quick recap, we have got 2 for sine. Can you pay attention? 2 for sine, 2 for cos. Right? And then 1 for tan. Total 5. Right? Now, any question which will ask you to determine the general solution of any trigonometric equation, this is what you need to remember. Okay? But I need to emphasize that this is called the reference angle. That's your reference angle. This is your reference angle. That's the angle you get from your calculator when you press shift cos, shift tan, shift sine. So this is your reference angle. Okay? Now because these trigonometric graphs are periodic, which means they repeat themselves from minus infinity to positive infinity, we have to consider the periodic nature of those graphs. That's why we end up with this part. This part it caters for the periodic nature, which gives us many solutions. For one value of y, you have many solutions. Okay? So these equations or formulae, they generalize or they simplify all the possible solutions to any trigonometric equation. Last year in grade 10, you were always given a restriction that theta lies between 0 degrees and 90 degrees. Okay? That was just a way of simplifying things because you were in grade 10. In grade 11 and 12, things are going to change. You are going to encounter some very complex trigonometric equations. And you need to know that the angle can not only be in the first quadrant, it can be in the second, depending on the sign of the ratio. It can be in the third quadrant, fourth quadrant, and so on. You can have values that are more than 360 as well for theta or x, whichever the reference angle will be. All right, so let's move on to application now. Okay, application. So let's start with number 1. So we have sine theta. This is a grade 10 equation. But the question here says determine the general solution. Okay? If it was in grade 10, you are not going to get those two as general and solution. You're going to get a restriction which says theta lies between 0 and 90 degrees. Okay? But now, that is gone now. Because you are doing a little bit more advanced trig. So, if I want to get the general solution, because this is a trigonometric equation in terms of sine, which means I must get 2 general solutions. I must have 2 because we are dealing with sine there. The ratio is positive. Since the ratio is positive, we have to determine the general solution based on the first quadrant where sine is positive, second quadrant where sine is also positive. Okay? Now it's not complicated. Just use these 2. 1, 2. We are going to use, let me just highlight with a different pen. Maybe green will do. So we're going to use that general solution or that formula and that one, those 2. Right? The only difference that when we have got shift the value of a there, we are going to put root 2 over 2 there. Okay? So theta will be equal to shift sine of root 2 over 2 plus k times 360 degrees, where k is an integer. Right? Fortunately, I know that root 2 over 2 gives me a special angle, which is 45 degrees. So that's the first general solution for that trigonometric equation. Okay, please take note. This formula here is the one which is called the general solution. Okay, it generalizes all the possible solutions. Now, since our reference angle, this is our reference angle by the way, that's 45 degrees. Now, there is no mark given, because I know some of you are going to go for tuition. There is no mark given for writing reference angle equal to 45 degrees. There is no mark given for that. You should know that the angle you get from your calculator, that's your reference angle. Okay? And that's not complicated to understand. Okay? There is no mark given writing reference angle equal to, no. Right? Then, our second solution, it will be equal to theta. Since this reference angle is acute, it has got a sister or a brother in the second quadrant, okay, and that angle will be obtuse. Yesterday, I explained to you how to get that angle in the second quadrant. What do you do to get the sister or brother in the second quadrant? You subtract this acute angle from what? 180. So it means, okay, I'm going to write it down for now, but in future I won't write it. So 180 degrees minus 45 plus k times 360, where k is an integer. So your theta is going to be 135 degrees plus k times 360 degrees, where k is an integer. Alright? So I'm done now with my two general solutions. This is sine, so it has got two general solutions. So these will be the two answers. Okay? Those two. Those are the two general solutions. No. It will probably be 3. Okay? It will be 3. This is how it's allocated. So you get 1 mark for that. 1 mark for writing that k is an integer, and 1 mark for the other. So this question is very simple, so 3 marks will be fine. Okay, always don't forget to write that k is an integer. We'll give you a mark for knowing that k is an integer. Are you following that? Even if your formula is not correct, but if you wrote k is an element of integers, you get 1 mark for that. Okay? Right? Now, just to take you further, because you might be asking then, how am I going to find theta? No, we don't have to find the actual value for theta, because there are so many values of theta that can satisfy this equation. It's actually an infinite number. You can't write all of them. There are so many. So these two formulae here, they simplify how to get all those solutions. Okay? So let's just test one, for example. I want to test one which is more than 360 degrees. Right? So if I want to test one, I'll just put k equal to 1 here. So 1 times 360 will get me what? 360. 360 plus 45, I'll get 405 degrees. Talking about that one. The second one, if I put k equal to 1 here, 1 times 360, 360 plus 135, I'll get 495. Right? Now, if you can test with your calculator, sine 405 to give you root 2 over 2. Do it. Do it. So don't be a spectator. Do it. Okay? Sine 405, root 2 over 2. Sine 495, you get root 2 over 2.
So if you want the value of sine and it's less than 360, you already come up with these two equations.
You want the value?
You want it less than 360.
Then you substitute k equal to 0. Remember, k is an integer. So you substitute k equal to 0.
So then it'll be your reference.
Your reference angle is this way. The first angle you get from your calculator, that's your reference angle. The angle you get from your calculator, that's your reference angle. This 135 is no longer a reference angle because we determined it by using that. Your reference angle is the one you get from your what? Calculator. Please take note, this is the reference angle. The one that you get from your calculator, that's your reference angle. Okay? Now, let's say we had a restriction which says the values of theta must be between 0 and 360. Okay? If the values of theta were supposed to be between 0 and 360, it means where there is k here, you put 0. Where there is k there, you put 0. You get two answers, 45 and 135. If you substitute 45 there and 135, you get this ratio. Okay? Are you following that? So I'm done here. Right? Listen, can I have your attention? There is no mark allocated for writing quadrant 1, quadrant 2, what, because I know you hear, you go for tuition, there is no mark allocated, you'll be wasting unnecessary time. Memorize this formula, then you are done. You'll be okay. You can teach anyone with this, the general solution. Alright, let me carry on. Right, so we have done that. Let's move on to 1 with cos. Okay, like that number 2 there, cos. Okay, let's do this one which is negative. So cos A equal to minus a quarter. Cos A equal to minus a quarter. Right? Now, because this is cos, okay, because this is cos, and the ratio is negative, okay, we know that cos is negative in the second and the third quadrant, okay? But whether we know that is not a big deal, formula, that's it. So right here, A equal to plus or minus shift cosine of minus a quarter plus k times 360, where k is an integer. Now shift cosine of a quarter of minus a quarter will give you what? It should be plus or minus. What is shift cosine of a quarter of minus a quarter? Huh? 104,48 degrees. Right? Plus k times 360, where k is an integer. Now check this. I can just write it plus or minus 104,48 degrees plus k times 360 degrees, where k is an integer. And I'm done. Because this caters for both second, third quadrant. Okay? Now, this is the part which, okay, sometimes it irritates me actually. I'm sure you can agree with me here that our reference angle is positive 104,48. But because of the plus or minus, the second angle is going to be what? Negative. Negative 104,48. Now, in which quadrant is negative 104,48? To be in the what? To be in the third quadrant. Now, there is no reason. Okay, can you pay attention? There is no reason why you can decide to change the minus 104,48 to a positive angle. It doesn't help because it's the same thing. Okay, I hope you understand what I'm saying. So what I'm saying is this: minus 104,48. It's in the what? Third quadrant. It's a negative what? Angle. There is a positive angle which corresponds to this. Right? If you put this where there is A there, you get that ratio. If you put the positive of this, you also get the same what? The same ratio. So what is the point of wanting to rewrite it as a positive? There's no what? There's no point. Check this now. If you put K, listen, pay attention, because I want you to teach others the general solution. If you put K equal to 1 there, right? If you put K equal to 1, if we take the negative of this, you get the positive angle. Am I right?
Yes.
Huh? You get the what? The positive, which is also in the third quadrant, and it gives you the same ratio as this. Right? Then, if you were to convert this one here and say, okay, you want to use the positive of it. Okay, it will be what? 360 minus this will give you what? It will give you 245, what? 55. 255,
5,
52. Let's say you replace the negative of this number here by this angle. You put it here, right? There is a plus k times 360. If you substitute k equal to negative 1, you get this. I hope you are following what I'm saying. If you take the positive of this angle, which is in the third quadrant, if you put it here like this, 255,52 plus k times 360. If k is negative, remember k is an integer. If you put k equal to negative 1, you get this angle. Do you see that?
how do you add the 360 days?
Okay, why am I saying this? There is no rule which says the angles that you must put there must always be positive. Because angles can be negative and they can be positive and they can give you the same what? Ratio. This is the ratio here. That's the ratio. Okay, otherwise if you're doing more like a double job, you get an answer which is negative. You want to make it a positive, but if you substitute in the original equation, both of them give you the same what? Ratio. Are you following? Huh? Yeah, so if you go for tuition, you must ask your tutor, why do you have to convert this to a positive when they give us the same ratio? Yes, sir. Third quadrant. Okay, please be aware that in grade 11, you work with both negative angles and positive angles. The cosine of a negative and the cosine of a positive will give you the same result. Okay, all right, so I'm done with that. Then let's move on. Okay, let's do another one with tan now. So we have got tan equal to minus 1 over root 3. So that's number 6. So tan theta equal to minus 1 over root 3. Now tan is very simple. Tan is very simple. It has got one general solution. So this will be theta equal to shift tan of minus 1 over root 3 plus k times 180 degrees, where k is an integer. What is shift tan of minus square root of, minus 1 over square root of 3? Minus what? Minus 30 degrees plus k times 360. Huh? Oh, sorry. Supposed to be 180. Okay, sorry, I put 360 there by mistake. So this is 180. Okay, again, I'm going to say this. There is no reason why you have to convert that to a positive angle. Right? Why? Because this angle is in the what? In the fourth quadrant, tan is what? Negative. So even if you decide to convert it to a positive, okay? Because of this k here, if you substitute a specific value of k, you still get this negative 30. Okay? So there's no need to convert it. This k here, it caters for all the values, whether they are negative or they are what? Positive. Because it's an integer. Okay? If it was a natural number, that's when maybe it would matter. But in this case, k is an integer. Therefore, all negative angles and all positive angles. Right? And this is our reference angle. And this is our answer actually. No stress. This is your answer here. Yes. You know what? Over the years, I've come to realize that I don't know why you learners have a problem with the general solution, because it's so easy. If you understand the concept, it's so easy. Okay. With the K part, you never told what value of K is. The only thing that you can be told is you can be given a restriction for theta, which can say, okay, all right, I'm going to just ask you to determine all the values of theta between 360 degrees and 360 degrees. Can you find all those values using the general solution? Determine for this equation, find the actual values of theta between minus 360 and 360 degrees. That's your class exercise, huh? If you want to find all the solutions, you use the general what? Solution. You don't have to stress yourself. Once you get your general solution, if it's correct, then you can use it. So, in this case, if you have got that restriction, means your theta, you start from k equal to 0. When k is 0, theta will be what? Minus 30. Okay, and minus 30 is in that interval. Then you go to k equal to 1. Okay, so 0, then k equal to 1. If you put 1 where there is k there, you get 180 plus minus 30, and that will give you 150. Right? And then k equal to minus 1, you get minus 180 minus 30, you get minus 210. And then k equal to what? To 2. 2 times 180, that will give you 360 plus minus 30, you get 330. Right? If you try k equal to minus 2, listen, k equal to minus 2 give you minus 360, minus 30, you get minus what? 390. Minus 390 is not in that interval. So what that means is, these will be the 4 solutions. Okay? There will be the 4 solutions based on this restriction. But it doesn't mean that they are the only solutions. They are not the only solutions. There are others that are more than 360 and others that are less than minus 360. Okay? It's just that because there are so many of them, we just restrict you to give us just a few of them. Okay? Are you following? Yes. So if you put all these angles here, where there is theta there, you get this answer. That's why there is no reason why you have to convert a reference angle which is negative to a positive one, because even a negative angle can be a solution to a trigonometric equation. Yes.
So if your restriction was 0 at 90, right? 10, you half 180.
See, generally, we determine theta, not the k, right? So, depending on the ratio you have here, this one to give you this reference angle. Then from the reference angle, you can then use the try and error in terms of the values of k to determine all the possible solutions based on a specific restriction. The restriction will be given if it's a test. Okay, but it mustn't be too wide, otherwise you spend a lot of time on a question on the general solution. All right. Now that you have been introduced to doing. Okay, so first thing, we have to divide by 4 on both sides. Right? So we divide by 4 on both sides, and then we get cosine of theta over 2 plus 10 degrees. This is equal to minus 3 over 4. Remember, this is from grade 10, this type of trig equation. The only grade 11 concept which you are bringing in is the general solution. Then, you take the cos to the right, so end up having theta over 2 plus 10 degrees equal to shift cosine of minus 3 over 4. Okay? What is shift cosine of minus 3 over 4? It's what? 138, comma 9. Now, it's very important for you to know that your reference angle It is the angle you get from your calculator. So our reference angle is 138,59. Therefore, we have to put plus or minus there. Then we add, well, this is cos, we add k times what? 360, where k is an integer. Then we need to carry on solving. Okay? We are solving for what? For theta. Now, for this question here, we might have to break it up into two. The positive reference angle and the what? The negative one. So I'm going to start with the positive reference angle. Okay, because these two here complicates things, but I can work with it as it is, but it complicates things, so we end up having theta over 2 plus 10 degrees is equal to 138,59 plus k times 360, where k is an integer. Then we multiply both sides. Okay, I'm sure you can see that we have a 2. We have a 2 on the left hand side, which is a denominator. So the denominator of that is a 1, of that is a 1. Denominator of the k times 360 is also a 1. So we multiply everything by 2, we get theta plus 20 degrees is equal to, this times 2, it will give me 277,18. Can you just check for me there? Because of this theta over 2, we want to make theta the subject. So find the LCD. So 2. Then you multiply every term by what? By 2. So is this correct? Right? Plus k times 720. And then theta will be equal to, take this 20 degrees, then get 257,18 degrees plus k times 720, where k is an integer. Are you following there?
So why do you say 2k?
2 times k.
What is 2 times k times 360?
K times 360.
It will be k times 720. Okay, please, I hope you are not going to be affected by the fact that today is a Friday. So you have got this, right? You have got that. K times 360. Are you aware that you can just multiply the 2 by the 360 because of multiplication? Then you get what? 720. Generally, you don't multiply the 2 by the k. Because remember, k is an integer. We don't want the coefficient to be more than 1 or less than 1. Let the k remain on its own. So you multiply the 2 by what? 360. Are you following?
Yes.
Okay, it's a good thing that you are asking. I said, because of the nature of this equation, it has got 2 terms on the left. Let's break this up. Let's start with the positive reference angle, then we'll do with what? The negative separately. Yeah. So I found the general solution for the positive reference angle. Right? Now I'm going to say O, then I'll write again theta over 2 plus 10 degrees is equal to minus 138,59 plus k times 360, where k is an integer. Again, we multiply by what? By 2 throughout. We get theta plus 20 degrees equal to, multiply that to get minus 277,59 plus k times 720. So this will give you theta equal to minus 297,59, right? Plus k times 720, where k is an integer. So we have our 2 general solutions, this one here, and that one there. So these are our 2 general solutions. These 2. Yes?
Yeah. So, one is 17.
277,18. Okay. 277,18.
Yeah.
This one should be 18. Okay.
So where would you get your mark?
Okay. Now, let's test this. Okay, for interest sake, let's test it. We have got 5 minutes. Right? So let's say we choose k equal to 1. Right? K equal to 1. Alright? Put k equal to 1 into that equation. K equal to 1 here. You will get theta equal to 977,18. Okay? Please be aware that because we rounded this off, okay, it might affect our answer slightly, but can you substitute this into the original equation? This one here. This one here. Put theta there.
So what was K be?
I said, let's say k is 1. It means 1 times 720 plus that, we get this.
Yes.
So take this angle here, substitute it into the original equation, put it there.
Oh, okay.
Please do it.
Don't be scared.
Yes, don't be a spectator.
Open.
So it's this angle here, put it there where there is theta.
Yeah, it's pretty.
So it's 4 cos.
Technically, what
So it's supposed to minus 3 if you round it. Then it's because of the rounding.
Yeah, because of the rounding. So it's correct because of the rounding. Because you see, remember we round off to 2 decimal places, but the other digits. Those digits are the ones who positive because the minus 3. What answer again? You should get minus 2,999.
Yes.
Right? Which means this is fine. Okay? You can test another value you want. You can even use the second one as well. You substitute k for any value you want there. And then test that value in the equation.
So this one, the values don't be like plus minus the same.
What do you mean?
Plus minus 25718. It both have different values. Usually when you got the general solution, you say plus minus 41. But now I see for this one here, we have two different.
We are talking about this part here.
Yes.
You know why it's different?
Because the negative 3, that one is negative. One is the original angle.
Okay. You see this? It's different from that. Oh, sorry, from this one rather.
That one is negative.
Right? This one is positive. Right? It's in the third quadrant, isn't it? This one here, minus 2997. It's in which quadrant? There. Right? It will be in the minus 297. It will be in which quadrant? It will be there. It will be in the fourth quadrant. Yeah. Okay. This one will be in the first quadrant. Yes. But cos of a negative and cos of a positive, they give you the same one? The same ratio. So with this one now, also because of this part, you see this, we have a binomial inside brackets. Because of that binomial now, the way you work with the general solution is to change, you split the positive and the what? Negative separately.
So the 138 is going to help us to get the final.
Yes. But it will be better for you to just split. You take the positive 38, you work with it separately. Then the negative 138, you work with it separately. Because of that binomial part inside brackets.